So just now Mr. Satya has updated that both the conclusions SFD BMD as well as the strategy summary table is uploaded. The remaining, that is theories of failure and deflection of the beam, that will be uploaded by evening. I've already given to them, but it seems to be still they has not uploaded. It will be uploaded by evening 6-7 o'clock. It will be, you can see it in the app. Both your theories of failure as well as your deflection of the beams. So we'll discuss some questions now here. So this is the first question, probably in the workbook. It was a gate old paper. It was conducted ISC Bangalore at that during that year. So for the simply supported beam as shown in the figure, determine determine maximum shear force and maximum bending moment. Determine maximum shear force and maximum bending moment. Maximum shear force and maximum bending moment in the simply supported beam. So now directly what a bracket is welded above, and which load is applied at the end of the bracket? Load is applied in the vertical direction. So directly it is equal to, either you can use the two dummy forces or directly what you have studied now. When the load is applied in the vertical direction at the end of the bracket, it is equal to one constant point load in the same direction and a couple. So how many loads will be at A? At B? One constant point load downward and a couple. Couple is what the direction now? Anti-clockwise, 10 into 0.5. Somebody want to use the dummy force concept, you can use it. But those you are thorough directly can put it now. Since the load is applied in the vertical direction, so it is equal to a constant point load in the downward direction. A couple, what the distance between B and E? 0.5, anti-clockwise direction. Now you can find out the reaction. Either you can use the always general method can be used, otherwise here you can use the superposition principle. If you want to avoid the general method, you can use the superposition principle. What is the meaning of superposition principle? Assume only 10 is acting alone. When 10 is acting alone, what the reaction at A? 10 into what the distance with the other end? 3. 30 upon 4. So what the reaction due to 10 kilonewton? 7.5. Assume what? Neglect this now. Neglect this now. So what the reaction due to 10? By using what? A 10 into distance other end? 30 upon 4. 7.5. When 10 is downward means this reaction is upward. 7.5. Next, assume only couple is acting. When a couple is acting, what the reaction? M by L. This couple is in which direction? Anti-clockwise. Then the reaction should be upward. 5 by 4. When a couple is acting, what? When sigma V 0, sigma M Z non-zero. Reactions are net moment upon the span. If you neglect this 10, 5 upon 4. How much is now? 1.25. It is the anti-clockwise mean reaction is upward. So due to 10 kilonewton is 7.5. And due to this couple, it is what now? 1.25. So total is what? A 9.75. Due to constant point load, 10 into what the distance with the other end. Next, due to couple, M by L, 5 by 4. So this will be 9.75. So automatically, what about this reaction? RA plus RC should be equal to net vertical load. So this 10 downward means this reaction will be upward. Those are not any doubt, you can go for a general method. Sigma V equal to 0, sigma M equal to 0. So what you have done it here now? You want to get a clarity, you can put it like this now. Superposition. This load is at 10 kilonewtons. So what this reaction now? Load is downward means reaction should be upward. 10 into 3 upon 4. 7.5. And what about this reaction now? 2.5. Next, assume only couple is acting alone. Sigma V 0, sigma M is non-zero. This is the anti-clockwise. The reaction should be upward. So what is the reaction of 5 by 4? 1.25. And what about this reaction? 1.25 downward. Now I can add it now. 7.5 plus 9.1.25. Sir, 8.75 it is not. It is 8.75. And what about this now? 2.5 minus 1.25. It is a 1.25. I written correctly only, but I made a small mistake in the addition now. So this method you can use it now. Otherwise, you can use the sigma v equal to 0, sigma m equal to 0. That is always is valid now. Now, what is the shape of the SFD BMD? SFD consists of 3 vertical lines, BMD consists of 1 vertical line. Horizontal reactions are 0. Horizontal reactions are 0 because there is no axial load. So left hand side upward is positive. Here bend moment is 0. 0. At both the ends bend moment is 0. At the extreme end bend moment is 0. So here how many times you have to calculate? 2 times. Bend moment how many times you have to calculate? 2 times. First neglected. So what the, if you neglected, what the bend moment? 8.75 into 1. Positive. And it is anti-clockwise. Clockwise positive means anti-clockwise negative. 8.75 minus 5. So this is 3.75. So this is the maximum bend moment. In the workbook questions, question number 1 is like this only. It asks the maximum bend moment. Maximum bend moment will be 8.75. So it is the bend moment or bending couple. For both the member what now? AB is acting as a sagging bend moment of 8.75. For right side portion, it is acting as a sagging of 3.7. What is this height now? 5 kilonewton meters. So maximum shear force is 8.75, maximum bend moment is 8.75 kilonewton meters. Now the same question is like this. Okay, let me complete it now. Now repeat the same question now. Previously load is the vertical direction. Now load is applied in the horizontal direction. So it will be equal to how many loads now? Directly what now? One axial load towards right side. One couple. One couple is what a clockwise. Once again, what for the simply support beam as shown in the figure. Maximum axial load, maximum shear force, maximum bendment in the simply supported beam. So directly this will be equal to, those who are having any doubt, you can enter the dummy forces now. Already I explained, directly I am doing now. So generally is a standard question. Most of them are going to make a mistake now. So this will be about a 10 kilonewtons towards right side, 10 kilonewton towards right side. And this will give a couple in about a clockwise. Now, this is what a statically indeterminate. Now this beam will become a statically indeterminate. How many reactions here? 2 and 2. So horizontal reactions are 2, vertical reactions are 2. So it is a statically indeterminate. Yesterday I explained this now. So what the vertical your hinge support, how many reactions now? 2 horizontal, one vertical and 1 horizontal. Now how to keep the horizontal reaction? Net axial load is what? Towards right side. So reaction should be towards left side. And what about the vertical reactions now? What the vertical reaction? This axial load is balanced by the 2 horizontal reaction. Now this couple will be balanced by the vertical reaction. This net couple in clockwise, therefore reaction should be downward. superposition principle. That is what the first assume only axial load alone. Next couple is alone. So when this couple is what a clockwise, therefore reactions are equal and opposite. It should be a downward. And here it should be upward. First you are assuming the 10 alone, next couple is alone. When the couple is alone, what a sigma V 0, sigma M is non-zero. So what the reaction now? Net moment is what? A net couple is what? A sigma M is clockwise. So reaction should be a downward. How to find out this reaction? Net moment upon the span. What the net moment? Now 10 upon 4. 10 upon 4. It will be, so it will be 2.25. Next, we can use this statically indeterminate bar fixed at both the ends. So how to find out this horizontal reaction? When bar fixed at both the ends, what you have done it now? By using the shortcut method, horizontal reaction equal to load into distance with other end. So now, so this 10 and REH opposite direction or same direction? Opposite direction, therefore the plus. What the distance with other end? 3. So 10 into 3 upon 4, 7.5. And what about this reaction? Sum of this reaction should be 10, therefore this should be 2.5. Otherwise, if anybody go for the general method, now you have to use the 4 equation. What are they now? Sigma H0, sigma V0, sigma M0. Then total change in length should be equal to 0. But those you are going to this shortcut method, it will take the less time now. So once the reactions are completed, you can do the remaining now. Those you are getting any doubt, you can split it like this, now superposition. Superposition means each load is acting alone. So this is about bar fixed at both ends. When you have studied the bar fixed at both ends, what you have studied now? In place of the 2 fixed ends, you can use the 2 hinge supports. 2 hinge supports. Here you are going to get how many reaction? Horizontal reaction. What is the net axial load? When bar fixed at both the ends. For the shortcut method you have done it now. When the shortcut method is valid, when axial rigidity is same. Means default you are assuming the beam is prismatic and same material. Beam is prismatic and same material. They can use the shortcut method. So what is the net axial load? Towards left side. Net axial load is towards left side. So reaction should be towards right side. RAH. Now both are opposite direction plus. What the distance with the other end? 3. And automatically what this horizontal reaction now? Sum of the horizontal reaction equal to 10 kilonewtons. So directly this reaction will be and this is what the sigma V0, sigma m is non-zero. When sigma V0, sigma m is non-zero. So what the net couple now clockwise, therefore reaction should be a downward. 10 upon the span, what the span of 4. So 2.5. So there also I made a small correction here. 10 by 4 is 2.5. 10 by 4 is 2.5, therefore it should be upward. Ten by 4 is 2.5. Otherwise, if anybody go for a general method now, he has to use the 4 equations now. Sigma V0, sigma M0, sigma H0, but unknowns are 4. 4 unknowns cannot be determined with the help of the 3 equations. Then you have to go for a compatibility equation. Change in length should be equal to 0. So here this should be 10.5. That's all. What the maximum axial load? Maximum axial load is 7.5 tensile. Maximum compressive load 2.5. Now can you give at A directly loads now? What the axial load? 7.5. What the shear force? Minus 2.5. Bend moment is 0. The extreme end. Axial load is 7.5. Sometimes they will ask only at A. If you ask at A, axial load is 7.5 tensile, shear force minus 2.5. And we ask at C, what the axial load? 2.5 compressive. And shear force is what? Minus 2.5. Bend moment is 0. And if you ask at B, how many times you have to calculate the axial load? 2 times. Axial load should be calculated 2 times. Bend moment should be calculated 2 times. And shear force should be 1 time. Otherwise, you can go for the diagram. Is a statically indeterminate beam. Statically indeterminate. Yesterday I studied now. 4 unknowns cannot be determined with the help of the 3 equations. So maximum tensile load is 7.5. Maximum compressive load is 2.5. Then what about the SFD? Rectangle. Because of what? There is no, in between A and C, there is no constant point load. There is no vertical load. Between 2 constant point load, if there is no vertical load or no distributed load, it will become as what now? Shear force constant. SFD the rectangle. Negative rectangle. What the bendment here now? 0, 0. You have to calculate 2 times. Neglected. If you neglected, what the value now? 2.5 into 1. 2.5 into 1 minus 2.5. Another clockwise positive. What the answer for the first question now? 7.5 tensile. Maximum shear force is 2.5 negative, means it will form a couple in anti-clockwise direction. And maximum bendiment is 7.5. Sagging kilonewton meters. How to check it now? Number of vertical line ALD equal to number of axial load. How many axial load? 1, 2, 3. 3 vertical lines. SFD 2 vertical line. BMD 1 vertical line. So like this, so many questions are going to be there on this now, this step now. Sir, I want to go for a general method. I want to cross check it. Use the word which equation now? Sigma h is equal to 0. Sigma v is equal to 0. Sigma m is equal to 0. Then compatibility equation. Total change in length of the beam should be equal to 0. Now, if you ask the same question now, this you are done for the simply supported beam. Now, if you ask the same question like this now, determine axial load, shear force, bendiment at different cross sections of the structure. We have done it for the default simply support beam. But if you ask the same question now, determine axial load, shear force, bendiment, twistingment at a different cross section A, B, C, D, E for the structure. We have done it for the beam, but sometimes the question will be entire structure is asked now at different cross sections of the structure, then what do you have to do it now? In that case, you have to draw the free body diagram for all now. You have to draw the free body diagram for all the members now. Determine maximum axial load, shear force, bendment. At different cross sections of structure, different cross sections of structure as shown in the figure. Different cross section of structure as shown in the figure. Sometimes the question will be here, how many loading diagram possible in DE? DE member a pure axial load, only ALD. For DB member, what is 10 kilonewton? DB member, the 10 kilonewton is a constant point load. The BD will become as about a cantilever beam subjected to point load. Which type of load now? For DE member, the axial compressive load. For BD member, the transfer shear load. And for the beam ABC, it is the eccentric axial load. Now, if you ask the at different cross section of the structure, that is A, B, C, D, E, then what should be the first step now? Draw the free body diagram for DE. This DE member is supported by which member now? DE member supported by BD member. And the BD member is supported by the simply support beam. And this simply support beam is supported by the external supports. Simply support beam is supported by the external supports. For DE, DE is supported by BD member. BD member is supported by the beam ABC. But who is supporting the beam ABC? For this one, external supports are there. For DE, BD there is support, and for BD, simply support beam is a support. And for this one, we need a supports are required. Now, can you draw the first free body diagram for DE? Now, DE member is not in equilibrium. Equilibrium means sum of the horizontal force, sum of the vertical force, sum of the men should be 0. It is not in equilibrium. So, to keep this equilibrium, what is required now? We need a one horizontal reaction required here now. But who will provide now? For this one, which is acting as support, BD. So, BD will offer a reaction. So, this is action or reaction. Reaction provided by the BD. For DE, BD is acting as a support. Now, can you draw the free body diagram for BD? Now, the reaction or action or reaction, then action will be which side? Now, towards left side. action and reactions are equal but opposite direction. So for this 10 kilonewtons, the action of DE onto BD. Now I can check it now. This reaction acting as which load for this member now? Axial compressive load. But this action acting for this member is about now? Constant point load. The reaction provided by the BD member for DE is becoming the axial compressive load. But action of DE onto this member is about now? Constant point load. Now, this member is not in equilibrium now. In the previous case, sigma h was not 0. So because of this one, sigma h is 0, equilibrium. In this case, sigma h is non-zero. Sigma h is non-zero. So we need about now one horizontal reaction towards left or right. Now it is going towards right side. So horizontal reaction is going to be towards left. But who will provide that now? For this one, which one is acting as support? AC is acting as a support. So AC will provide a reaction. AC will provide a reaction. So this is a reaction provided by the AC member. But how this reaction acting now? What type of load? This reaction acting as a constant point load. This reaction acting as a constant point load. Next. What the moment due to this now? 10 into 1. What the length of this member now? 1 meter. What the net moment at B? What the net moment at B? 10 into 1 is a clockwise. Is in which plane now? Vertical plane. So the reaction will become as a bending or twisting now. For a vertical member, twisting couple is in a horizontal plane. But the 10 into 1 is a vertical plane. Therefore, this will become as what now? Reaction should be 10 anti-clockwise. 10 anti-clockwise. But that reaction will become as what now? Bending couple or twisting couple or bending couple. For horizontal member, twisting couple in horizontal plane. But this you are getting in what? A clockwise in vertical plane. So reaction will be our vertical plane in anti-clockwise. So it will become as a bending couple. So once again, this is a reaction provided by this beam. Reaction provided by the beam. This moment reaction acting as a bending couple. But horizontal reaction acting as a constant point load. So this look like a cantilever beam fixed at the B, subjected to constant point load. So here how many loading diagrams are possible? Here only ALD. But here one SFD, one BMD. What is the SFD? Between two constant point load, shear force constant. SFD is a rectangle. What the bendment here? No, 0. Here bendment is going to be what now? Bendment is what? Minus 10. It's going on which side? No, right side. Right side contraction is going to be negative. Left side contraction positive. So SFD will be a rectangle. BMD will be a triangle. But what the SFD positive or negative now? This and this. These two are forming a couple in which direction? Clockwise. When the shear force are forming a couple in clockwise direction, shear force positive. Therefore, SFD is a positive rectangle. But what about the BMD here? Bendment is 0. Here bendment is what now? Going on the right side. Right side contraction means negative. So bendment at B is minus 10. So here you are getting only ALD. What is the shape of the ALD? Negative rectangle. Here what how many shape of the diagrams are possible? SFD and BMD. What is the SFD? SFD is a positive rectangle. SFD is a positive rectangle. But what about the BMD here? Bendment is 0 here. Bendment is minus 10. BMD is a negative triangle. Now can you draw the free body diagram for AC? So these are all the reaction or action or reaction. So this reaction, what is the force reaction towards left side? So action will be towards which side now? Right side. This reaction is towards left side. So action will be towards right side. Now you can see once again now, this reaction acting as a constant point load, but action is becoming as a axial load. Next, what is this reaction? 10 kilonewton meter in vertical plane. 10 kilonewton meter in vertical plane. Reaction. But what about the action? Same plane. Plane will remain same. Only direction changes. But this will become as a bending or twisting. Is in which plane? Vertical plane. Every bending couple will not become as a bending couple for other member. For a vertical member, twisting couple in horizontal plane. Remaining two are a bending couple. So this in vertical plane means here also vertical plane. For horizontal member, twisting couple is in profile plane. But this couple in which plane now? Vertical. Therefore it become as a bending only. Starting you are given the differences between the bending and twisting. Previously, you have drawn directly the free body diagram for the beam. How you have drawn it? Using the two dummy forces. Otherwise, this 10 kilonewton towards right means a 10 kilonewton towards right and a couple 10 into 1. Check it now. This diagram with the free bump, previous question, previous answer now. Compare this beam with the previous one. Same you are going to get it now. This member is not in equilibrium. So if this member should be in equilibrium, reactions are required, that supports are required. So external supports are required for which member? AC. For DE, which one is the support? BD. For BD, which is acting as support? AC. But for AC, we need an external support. Which supports are given now? Hinge supports are given. So this is just now you have completed. Now check it now. How we got this diagram previously? Using the two dummy force. But if we do like this now, we don't need any dummy force concept. First case what a DE only ALD. Here one SFD, one BMD. Here ALD, SFD, BMD all are possible now. Now what are the reactions studied now? What are the reactions here now? Ten into distant other end. 10 into 3. Just now you completed now. 7.5. So these are the reaction due to axial load. And due to couple, what are the reaction now? Due to this couple, reactions are downward. So just now you have completed this now. Here how many ALD, SFD, BMD? One ALD, one SFD, one BMD. But here only ALD. Here one BMD and SFD. No ALD. Now, without drawing the diagram, can you give the directly loads at different cross section at E? Either junction or non-junction, non-junction. Here only which load is there? Now constant at point load. So at E you are getting only shear force, Remaining three loads are 0. A is also junction or non-junction, non-junction. One axial load due to horizontal reaction 7.5. One shear force due to vertical reaction minus 2.5. And at C, once again, one axial load, 2.5 compressive. And what the shear force? Minus 2.5. Here, how many junctions are in this question now? D is also junction, B is also junction. D is also junction, B is also junction. D is the junction of how many members now? D is the junction of DE and BD. DE is the junction of DE and BD. So if we ask at D, you have to calculate with respect to DE and BD. Now can you tell it now? When D belongs to DE, if you ask at D, when D belongs to DE, what the axial load 10. But when D belongs to BD, what the axial load 0. Here there is no axial load. So when D belongs to DE, axial load is minus 10. But here axial load 0. What is the larger value? Now minus 10. And here there is no shear force. No constant. But here you are getting a shear force. This 10 and this 10, they will form a couple inward or clockwise. So shear force is 10. And what about the bend moment here? 0. And here also bend moment is 0. So at D, bend moment is 0. So total at D, how many loads are there now? At D, when D belongs to DE, axial load is minus 10. Here axial load is 0. If we ask at D, I have to take a larger value. If we ask at D, what is the larger value? Now minus 10 and 0. So axial load at D is what? A minus 10. Next, what about the shear force? Here shear force 0. But this directly become as a shear force extreme end. Directly constant at point load will become as a shear force. So directly this is shear force. But a positive or negative. This 10 and this 10 clockwise. Shear force is a plus 10. Next, bend moment here 0 because there is no couple. Here also 0. So at D, what the answers now? Axial load is minus 10. Axial load is minus 10. And shear force is what? A plus 10. Bend moment is 0. Twist moment is 0. Now, if ask at B, B the junction of how many members now? B the junction of BD and B the junction of AB and BC. So B belongs to how many members now? BD member, AB member and BC member. Now if we ask at B, what the axial load, shear force, bend moment and twist moment at B? What the answer now? When B belongs to BD, there is no axial load here now. But when B belongs to AB, what is the axial load? When B belongs to AB, what is the axial load? 7.5. When B belongs to BC, what is the axial load? 2.5. Otherwise, you have to neglect it, you have to do it now. So, what is the axial load here? No, 0. Here, when B belongs to AB, what is the axial load? 7.5. When B belongs to BC, what is the axial load? Minus 2.5. So what is the axial load at B? Larger of the axial load in BD, larger of the axial load in AB and BC. But here axial load is 0. But when B belongs to AB, axial load is 7.5. When B belongs to BC, minus 2.5. So the larger axial load is how much now? 7.5. Similarly, can you give the shear force now? Here what is the shear force? 10. Here shear force 10. Here you have to calculate the shear force 2 times or 1 time? Only 1 time. So when B belongs to AB, what is the shear force? Now minus 2.5. Even when B belongs to BC, 2.5. So what is the shear force at B? Larger of the shear force in BD. Here minus 10. Sorry, plus 10. This 10 and this 10 clockwise. So when B belongs to BD, maximum shear force is what? A minus, here minus 10, sorry, plus 10 clockwise. Here, when B belongs to AB is a junction, but this is not a junction, this is a junction of AB and BC. So when B belongs to AB, what the axial load? 7.5 tensile. When B belongs to BC, 2.5 compressive. When B belongs to BC, minus 10 or plus 10, plus 10. So what the shear force at B? Larger of plus 10, plus 7.5 and minus 2.5. So what the larger value? Not 10. And what about A and C non-junctions? So now In all the member, which load is 0? Twist moment is 0. No twist moment, no twist moment, no twist. Therefore, everywhere twist moment is 0. Whenever you want to get a twist moment, there should be a concentrated, twisting couple is required. Twisting couple, but nowhere twisting couple is there. Now, can you fill this table now? First, write down the non-junctions. How many are non-junctions now? A the non-junction, C the non-junction, and E the non-junctions. But how many junctions are there now? B the junction of how many member now? AB, BC as well as BD. So if we ask at B, I have to take the larger of the values in AB, BC and BD. But if you ask at D, D the junction of how many member now? DE and BD. So I have to take the larger of the values in DE and BD. You have to take it now. First I am completing the non-junctions. A. Non-junction. What the axial load? Directly to the axial load. 7.5 positive. Shear force. Vertical reaction will become a shear force at the extreme end. Left hand side downward is a negative, minus 2.5. Bend moment 0 because there is no couple. 0. Next, what the other non-junction? C. It is also non-junction. So directly this will become the axial load and this will become the shear force. So what the axial load? Minus 2.5. What the shear force? Minus 2.5. Because bendment and twistment is 0 because there is no twisting couple and bending couple at the extreme end. Next, which is the non-junction? E. Here only you are getting axial compressive load, no constant point load, no bending couple, no twisting couple. So how many loads are 0? No, shear force 0, bendment is 0, twistment is 0. So only axial load. Next, if we ask at D, D the junction of DE and BD member. Here what the axial load? Minus 10. Here axial load is 0. So what the larger of these values? Now minus 10. Next, here shear force 0. At extreme end to get a shear force 1 constant point load. But there is no constant point load, 0. But there is a constant point load is there 10. So shear force here 10, here 0. So once again what the larger value? No, 10. But plus 10 or minus 10. This 10 kilo and these two are forming a clockwise. What the shear force sign convention? Clockwise positive. So the plus 10. To get a bendment, at least one bending couple is required. Here also there is no bending couple. Here also there is no bending couple. So bendment and twistments are 0. Next at B. B the junction of how many member? Now B the junction of BD, AB and BC. If you ask only simply support beam, B the junction of AB and BC. But if you ask the entire structure, B the junction of BD, AB, BC. Now first axial load. What the axial load here? 0. This is the extreme end, but this is the junction. So this will be a distributed. So when B belongs to AB, you have to neglect it. When B belongs to AB, what the axial load? 7.5. When B belongs to BC, minus 2.5. Here 0. So what the larger value now? 7.5. Larger of axial load in AB, axial load in BC, axial load in BD. Because the junction of 3 members, therefore axial load is 7.5. Next, what about the shear force? Directly the shear force. What the shear force here now? Here how many times you have to calculate? Only one time. It has only one shear force. So when B belongs to BA, what the shear force? Minus 2.5. When B belongs to BC, what the shear force? Minus 2.5. So what the larger value? Here 10, Here SFD is a constant, shear force a constant. So here shear force 2.5 minus, therefore here also minus 2.5, here also minus 2.5. So what the shear force value now larger of plus 10 and minus 2.5. So plus 10. Plus 10. Next, what about the bendment now? Directly this will become as a bending couple or bendment, both are same because of extreme. But this is not a bendment. This is not a bendment because B is a junction. Here you have to calculate only one time. This is what now? Extreme. What the bendment now? Minus 10. Left side contraction positive, right side contraction negative. So when B belongs to BD member, what the bendment? Minus 10. But here 2 times. If you neglect it, when B belongs to AB, what the bendment now? 2.5 into 1. 2.5 into 1. So minus 2.5. Here minus 10. Similarly, when B belongs to BC, by neglecting 2.5 minus, if we consider 7.5. So what the larger value now? Here minus 10. When B belongs to AB, 2.5. When B belongs to BC, 7.5. So what the larger of the value now? 10. Minus 10. 0. Larger of the what now? B belongs to BD. Next, B belongs to BA. B belongs to BC. Because B belongs to 3 members. But this has become as the extreme. Directly this couple will become as the bending. So larger of minus 10. But this is a junction. When a couple is acting, 2 bending moments will be there. If you neglected, what the value? Not minus 2.5. Minus 2.5. 2.5. Next, you have to consider this now. Minus 2.5 plus 10. Plus 7.5. Sorry, larger value is 10, minus 10. Now sometimes they are asking the diagrams. Here how many diagrams now? ALD. Here SFD, BMD. Here ALD, SFD, BMD. Can you draw the diagrams? Already I completed SFD, BMD for this now. Now can you draw the, here how many diagrams are possible? Is a pure axial compressive load. Pure axial compressive load. No other diagram. But here how many diagrams are going to be there now? SFD and BMD. For the shape of the SFD, between two constant point loads, if there is no vertical load, shear force a constant. So SFD is about a positive rectangle because these two will form a couple in clockwise. And what about the bendiment here? No, 0. Extreme end bend. But this is about the bendiment. So this going on the right side. Right side contraction is going to be a negative. So what the BMD is a negative triangle. SFD is a positive rectangle. What about the BMD? Here bendiment is 0. This is minus 10. What the meaning? BMD is negative. What is the meaning of BMD negative here now? Right side surface gets contracted. Right side surface gets contracted. Some students are asking, sir, how you are taken right side surface contraction? Why you are taken the right side surface contraction? Why you are taken the left side contraction positive? Why you are taken the back side contraction positive? Why front contraction is negative? Top contraction, nobody will get it out. Top contraction positive means nobody will get it out because that is given in the textbooks now. Top contraction, sagging is positive, hogging is negative. There nobody will going to get it out. But here, sir, why you are taken the right side contraction negative? Why not left side contraction is negative? How to check it whether this diagram is correct or incorrect now? Some of the friends are there giving what now? When I asked during the mock interviews for the GATE and ESC, if I ask now why you are taken this negative, सर आपने क्लास में बोला था सर राइट साइड कंट्रैक्शन नेगेटिव लेने के लिए बोला था इसलिए नेगेटिव है सर. लेफ्ट साइड कंट्रैक्शन आपने साइन कन्वेंशन लिखवा दिया था backside contraction is going to be a positive, top contraction is about the positive, and left side contraction positive. But what is the reason? What is the reason? Slope of the Bendman diagram should give the shear force. Slope of the Bendman diagram equal to shear force. What you read in the morning? No? F equal to dm by dx. Slope of the Bendman diagram. What the slope of this diagram? Can you write down the slope now? Slope. You have to go from what the slope of this diagram. Dm by dx or dm by dy. You have to consider dm by dy. Dm by dy. Horizontal member means what? Dm by dx. Vertical member means what now? Slope of the Bendman diagram means what? Dm by dy. Can you write down now? You have to go from bottom to top or top to bottom. Y coordinate is positive upward. Y coordinate is positive upward. So how to write down now? Dm by dy of db portion. md minus mb upon yd minus yb. Now md is how much now? 0. md is 0. What the mb? Minus 10. mb is what? A minus 10. So minus of minus. And what the yd? What the yd? Positive. How much is now? 1. yd minus yb is how much now? 1. yd minus yb is what? 1. So what this value are getting? A plus 10. So this should be equal to shear force of now check it now. Are you getting shear force positive or negative? Shear force here taken positive. That's why here taken right side contraction is going to be negative. Right side contraction negative, left side contraction positive. Suppose if you are going to take the right side contraction positive, if you take the right side contraction positive, what about this now? 0 minus of plus 10. Then you are going to get a minus 10. Then the relation is not satisfied now. The slope of the Bendman diagram should give the shear force. But the shear force here now plus 10. Shear force the plus 10. The slope of this diagram should give the plus 10. By chance, I'm going to take the positive Bendman diagram. Positive means the plus 10. Then you are going to get a minus 10. Minus 10 means slope of the Bendman diagram is not giving the shear force. So why you are taken the left side contraction positive, right side contraction negative, top contraction positive, bottom contraction negative, back side is positive, front is negative. Mean what the answer na? Sir, if you follow the sign convention, then only the slope of the Bendman diagram will give the shear force. Then only the slope of the Bendman diagram give the shear force. And always you have to go for what? When a horizontal member means you have to go from left to right. Vertical member means you have to go from bottom to top, because y coordinate is positive upward. Y coordinate is positive upward. So this is the upper limit and the lower limit. So md minus mb. md is 0. mb is what? A minus 10. Minus of minus will become the plus 10. So this I am not drawing, just now you already completed SFD, BMD, ALD for this now. When this method is required now, if you ask a different cross section, if you ask at different cross section of the entire structure, but most of the question they are asking only that simply supported beam. But if you ask at every different cross section, you have to use this method now. is a workbook question. This is what now one of the civil service paper. It is nothing but what generally vertical member means a column. A column is hinged at both the ends. A column is hinged at the both the ends. And 4 statements are given us to identify which is the appropriate statement. What the maximum shear force, maximum bendment, and what the maximum axial load. So once again, what the is asking only on the column. What is asked the question now? What the maximum axial load, maximum shear force, maximum bendment on the column. But if you ask in this entire structure, if you ask the entire structure, then you have to go for that free body diagram for every member now. So determine maximum axial load, maximum shear force, maximum bendment on the column as shown in the figure. So you have to draw the directly free body diagram for this now. So directly what this load is the upward direction. How many loads at B? One axial load upward and one couple. So directly what only in the column is asked now. Same question here done it now by keeping the member the horizontal, but in place of horizontal member, vertical member is given. That the column is given now. So the bracket which load is acting now in the vertical direction. So it is equal to 1 axial load in the same direction. It is equal to 1 axial load in the same direction. Any doubt? You can use the 2 dummy forces now. Next, couple. This eccentricity is required now. This is 1 meter. So what this couple now clockwise, how much is now 10 kilonewton meters. So once again is statically indeterminate. So many questions are like this now. Whenever a hinge at both the ends and whenever an axial load is there, it is statically indeterminate. Now this 10 kilonewton balanced by the vertical reaction. How to keep the vertical reaction? Net axial load how much? 10 upward. Net axial load is 10 upward. So reaction should be downward. Now can you find out the reaction by in the shortcut method now? How to find out the RCV? This RCV and 10 are opposite direction or same direction. Bar fixed at both the ends or hinged at both the ends. This RCV and 10 opposite direction plus. What the distance between B and A? 4. 10 into 4. And what the span now? 5. So it will be 8 kilonewtons. And what about this reaction now? Sum of the vertical reaction equal to net vertical load. So it will be 2 kilonewtons. So vertical reactions are completed. Next, due to this couple, you are going to get a horizontal reaction. What is net couple? Clockwise, anti-clockwise, clockwise. Now horizontal reaction will be which side now? Net couple is a clockwise. The horizontal reaction should give a moment in which direction? Anti-clockwise. This is a clockwise. Therefore horizontal reaction should give a moment in which direction now? Anti-clockwise. How to find out this reaction now? When sigma m is non-zero. When sigma m is non-zero, what is the reaction now? Sum of the couples upon span. What is the sum of the couples now? 10. What is the span now? 5. Then automatically here reaction should be that's all. So for the axial load, maximum axial load. Axial load on BC equal to axial load at C. It is a plus 8 tensile. What the axial load in AB? Axial load at A minus 2. So what the axial load in the member now? Tensile load is 8 kilonewton. Compressive load is going to be 2 kilonewtons. So maximum compressive load is 2. Maximum tensile load is 8. Next, what the SFD? SFD is a rectangle. Between two constant point load, SFD is about a rectangle. But the negative or positive, this one and this one, they are forming a couple in anti-clockwise. For the shear force sign convention, anti-clockwise, negative, clockwise, positive. These one are forming a couple in anti-clockwise, negative. And what about the BMD? Here bendment 0, here bendment 0. But if you ask here bendment 2 times, you have to calculate now. If you neglect it, what the bendment now? If I take it above, 2 into this distance is what now? 4. But this giving a moment in which direction? Clockwise. Sir, anti-clockwise. Is going on which side now? Left side. Left side contraction positive. Therefore, if I consider above, 2 into 4, this giving a moment in which direction? Anti-clockwise. Going on which side now? Left side. So left contraction is a positive. So when B belongs to AB, how much is now? Plus 8. Means you are considering the anti-clockwise positive. Now this is a clockwise. So plus 8 minus 10 minus 2. So when B belongs to BC, what the value now? Minus 2. Otherwise you can see it now. Somebody is going to consider below. 2 into 1. 2 into 1 is going on which side? No, right side. Right side contraction is going to be a negative. Otherwise, you can draw the diagrams now. Everybody is going to draw the ALD correctly, but SFD, BMD, they are going to make a mistake now. Now I'm starting from the bottom. So the positive and negative, positive. So downward is the positive, tensile load is the positive. So this will be 8 kilonewtons. What the next step now? Draw a parallel line until next axial load. Next axial load. Since you have taken downward positive, upward is negative. So plus 8 minus 2. Plus 8 minus 10. Plus 8 minus 10 is what? A minus 2. Then draw a parallel line. Since upward is negative, downward is a positive, means upward is going to be negative. So it is also positive or negative? Positive. Minus 2 plus 2 will become as 0. So what the maximum tensile load? Plus 8. Maximum compressive load is 2. And between two constant point loads, shear force a constant. Between two constant point loads, it is going to be positive constant. But a positive or negative, how to take it now? Positive or negative, how to consider it now? These two are forming about now clockwise, anti-clockwise. Anti-clockwise means a negative. Between two constant point loads, the shear force a constant as long as there is no distributed load. So it is going to be minus 10. Otherwise, this had taken negative. Why you have taken negative? It is giving about anti-clockwise direction. Means downward I am taking negative. Sorry. Towards right side you are taking negative. Draw a parallel line to the long axis until next constant point load A. Towards right side you are taken negative, means towards left side is a positive. 0. Next, what about the BMD? Bendment is extreme end 0, no couple. At the extreme end it is 0 because there is no couple. But here how many times you have to calculate? 2 times. So I am neglecting this now. I have taken above. Bendment is what? Algebraic sum of moments. Above one moment now, 2 into 4. But this is going on which side now? Left side. Left side contraction positive. So what the value now? Positive. Eight. So you have taken anti-clockwise is anti-clockwise you have taken positive. From starting now. Why you taken this positive now? The anti-clockwise. Going on which side now? Left side contraction is positive. Since you have taken anti-clockwise positive, now this is a clockwise. So plus 8 minus 10. Plus 8 minus 10. Then here 0. What is the meaning of this now? Left side gets contraction. This is right side surface gets contracted. Right side surface gets contracted. What the other way you can check it now? The slope of this diagram should be equal to shear force. Slope of this diagram. Can you write down the slope of this diagram now? What the slope of the BC portion now? How to write down the slope of BC? dm by dy of BC. Always here y coordinate is positive upward now. Y coordinate is what? A positive upward. So what should I write now? MB minus MC. YB minus YC. What the MB? Minus 2. What the MC? 0. What the YB minus YC? 1. Check it how much you are getting now? Minus 2. What the shear force now? Minus 2. Between BC portion, what the shear force now? Minus 2. Similarly, what the slope of this diagram now? This will become the upper limit, this is the lower. You have to go for upward now. Y coordinate is positive upward. AB portion. Bendment at A minus bendment at B minus XA minus XB. What the bendment at A? 0. What the bendment at B? Plus 8. This distance how much now? 4. Then check it now. Minus 2. So what this value should give now? Shear force in AB. This should be equal to shear force in BC. This question only most of them are going to make a mistake in BMDs, because in all the textbook they are discussing only left side contraction positive, right side contraction is positive. They are all valid only in beams now. That is, beam is a horizontal member. But here they are going to get a doubt. Sir, is it sagging or hogging? Is it neither sagging or hogging? Sag means top contraction. That only I discussed now. With a water bottle I have shown it now. How many surface can be what now? When a member is vertical. When a member is vertical, how many surface gets subjected to what now? Either this is going to be twisted, this is twisted, cross sections are twisted. So always which surface are subjected to bending? Surfaces perpendicular to cross section. This is a cross section, cross section. So that is the top and bottom surface twisted. Which surface are subjected to bending? Surfaces perpendicular to cross section. Is a perpendicular, either right left side surface or right side surface or front or back side. Left contraction positive, back side contraction positive, right contraction negative, front contraction negative. Whenever you are indicating the reactions, your direction is required. What the RCH means, what should I write now? 2.5 towards right side. REH is what? 2.5, sir. RCH is what now? RCH is 2 towards right side. REH is 2 towards left side. In the workbook, the similar question is there. I slightly modified it because everybody is going to get a doubt. But there are, as the 4 statements are given, maximum shear force, maximum bendiment, like this now. Maximum axial load. So what the answers here, write down now. Maximum tensile load is how much now? 8. Maximum compressive load is how much now? 2. But maximum bendiment 10 is given now. This is not a bendiment, this is a bending couple. So many times you have studied now. Now we'll do some questions on cantilever beam, then we'll come to the distributed loads now. Cantilever beam, you can do the same now. Only reactions are going to be, we have to find out one vertical reaction, one horizontal reaction, moment reaction. And here SFD also they are going to make a mistake. They will remember only what now? Sir, left side contraction, upward is positive, sir, right side downward is positive, sir. But here's what now? Going right side and left side. That's why I given a generalized, first I defined the generalized sign convention for shear force. Then you are defined for the beam. For the generalized sign convention for shear force you are given now. Generalized sign convention for shear force is going to be when the what the shear force sign convention is given now. When shear force on either side of the cross section, when shear force on either side of the cross section forms a couple in clockwise direction positive, when shear force on either side of the cross section forms a couple in anti-clockwise direction is negative. That is the generalized, that is valid for any member now. You can, if you have any doubt, introduce the 2 dummy forces and you can decide it. If you are having any doubt in the direction of the for example, these are 10 kilonewtons. What do you have to do it now? Is it forming a clockwise, anti-clockwise? What if any doubt? This directly what a clockwise. Why you are getting a doubt now? Doubt is cleared. Right in the question now. First I will explain all the basics. If you are getting any doubts, go for the basics now, basic question now. For the cantilever beam as shown in the figure. For the cantilever beam as shown in the figure. Determine for the cantilever beam as shown in the figure. मजा आ गया. स्वराज पांडे. For the cantilever beam as shown in the figure, determine maximum shear force, maximum bending moment, maximum shear force, maximum bending moment, and location of point of counterflexure from left support. Location of point of counterflexure from left support. This question, if I ask the sum of the students, sir, I got the answer. How we have done it means, if I see his solution, he's kept that member the horizontal member. Vertical member is taken as a horizontal member is completed now. How can you take a vertical member, a horizontal member ना? सर ने मेरा सर ऐसा ही बताया था सर. हमको वर्टिकल मेंबर के लिए साइन कन्वेंशन मालूम नहीं है, इसीलिए वर्टिकल मेंबर को हॉरिजॉन्टल मेंबर लेके आप प्रॉब्लम कर सकते हो, इसीलिए मैंने किया, ऐसा किया था सर बोल के बोलता है. हाउ कैन यू टेक द वर्टिकल मेंबर वोट ना? How can you take a column as about a beam now? Then you can call the column as also beam also, you can call it now. He's attended my class also. Everything is that, but he's doing the what now? मेरा सर ने इसके पहले अटेंड किया था, ऐसा बताया था सर. Then you need not attend the classes now. You want to use the same concept, you can vote now. Why you are joining the medicine now? And why you are attending the classes now? You have to change yourself. Don't use the wrong concept or incorrect concepts now. Try to solve the, getting the answer is not a criteria. Every question is not like that now. सर मेरा आंसर्स मैच हो गया था सर, आपने बी एंड सी दिया था, मुझे भी वही आ गया. एक क्वेश्चन में मैच हो गया था, बट सभी क्वेश्चन वोट यू कैन नॉट डू लाइक दैट ना. सो डोंट मॉडिफाई, डोंट चेंज योर वोट द कॉन्सेप्ट एज पर द क्वेश्चन. फॉर वन क्वेश्चन वी कैन नॉट डू लाइक दैट ना. For the cantilever beam as shown in the figure, determine for the cantilever beam as shown in the figure, determine maximum shear force, maximum bending moment, and location of point of counterflexure. Location of point of counterflexure from fixed end. Now, can you complete this now? So, a bracket is attached at the free end. So, directly it is equal to what? Which load is applied? Now, vertical direction is applied. So, directly how many loads at A? A constant point load downward and a couple. Load is applied in the vertical direction. Therefore, it is equal to one constant point load downward and one couple. For the direction of the couple clockwise. Any doubt? You can use here two dummy force concept now. Now, what should be a first step? Reactions. Cantilever bearing reactions are simple. When you are studying the what now? Bar fixed at both ends in written now. Horizontal reaction equal to net axial load. But there is no horizontal load. The horizontal reaction 0. And what the vertical reaction? What the net vertical load? Net vertical load is 2 downward, 10 downward, 8 upward. So net vertical load is 2 downward. The vertical reaction should be 2 upward. And what about the moment reaction? Moment reaction equal to net moment at the fixed end. Net moment means what now? Most of them are going to make a moment reaction mistake now. Net moment at the fixed end. Net moment means sum of the couples and sum of the moments. So what the moment due to this now? 8 into. Find out the net moment at C. 8 into 2. Clockwise I am taking positive. Next 10 into 4. Clockwise positive means anti-clockwise negative I am taking now. Next is the clockwise. So what this value you are getting now? 16, 26 means minus 14. What is the meaning of minus now? Which one you have taken minus now? Which one you have taken minus? Anti-clockwise you have taken. So what should be the moment reaction? Moment reaction should be 14 clockwise. Clockwise. Now point of contrafixture will exist or will not exist? Is the bendment positive or negative? Directly this is the bendment. At A, what the shear force? Minus 10. Bendment is going to be what? A plus 10. And C, what the shear force? Minus 2. Here shear force negative, bendment is positive. And here once again shear force negative. Bendment is also negative. Both are negative. Right side anti-clockwise positive, clockwise is going to be negative. Right side anti-clockwise is going to be positive, clockwise is negative. So point of contrafixture will exist. That's why I checked it now. Before giving the numericals, I checked it whether point of contrafixture exists or not. By chance, this is about now. Is it an anti-clockwise direction? By chance, this is an anti-clockwise direction. Then at that time, point of contrafixture will not exist now. So can you draw the in cantilever beams? Horizontal reaction equal to or net axial load. and vertical reaction equal to net concentrated point load and what the moment reaction now? Equal to minus of net moment at fixed support. What the meaning of minus? Opposite direction. Minus means opposite direction. Already I use the same thing now. In this case, what the net horizontal force 0, horizontal reaction 0. What the net vertical load? 10 downward, 8 upward. Net load is 2 downward. Therefore, reaction should be 2 upward. What the meaning of minus? This minus sign is representing direction of the reactions are opposite to these directions. And in our case, what the moment, net moment we are getting now? 14 anti-clockwise. So it should be a clockwise. Now, SFD. Sometimes directly they will ask here itself now, what the maximum bend at C. Find out the axial load, shear force, bend at C. Axial load is 0, shear force is -2, bend is what now? -14. Once you find out the reaction for every beam, SFD BM is same. All the concept, whatever you have discussed, everything is same. Only beam to beam calculation of reactions are changes. That's why I have taken so many examples here done. All are going to be valid here now. So left hand side, I am starting from the left side. Left side downward is negative. Upward is positive. Next, draw a parallel line. So -2. Upward is positive, 0. SFD is close means your vertical reaction is correct. Vertical reaction is correct now. If SFD is not close means your vertical reaction is incorrect now. Is anti-clockwise, clockwise, clockwise, positive. Here bendment should be calculated 2 times or 1 time, only 1 time, because only constant point load. When a couple is acting, you have to calculate the 2 times. Therefore, at B, but you have to consider left side or right side now. Left side, anyone you can take it now. At B, you have to calculate only 1 time, left side. What is the value now? This is minus 10 or plus 10, plus 10, and this is what now? 10 into 2. So it is how much is now? Minus 10 will be there now. What the bendment at B? Plus 10 and 10 into 2. Anti-clockwise negative. 10 minus 20 minus 10. So whenever a shear force constant bend moment varies linear. So this is a point of counterflexure. Can you give this directly this location? Now these two triangles are similar and identical. These two triangles are identical. So we don't need any method now. Directly can get it now. This height is 10. This height is also 10. So directly this D will be between A and B. So what is this distance now? 1 meter. Next, what the bendment here now? Directly this itself bendment. This itself bendment now. Right hand side anti-clockwise positive, clockwise is negative. So this slope should be less than this now, because here shear force is what, 2. So slope of the what now? BMD should change. If you don't, somebody is going to put it like this directly, they'll get a single straight line. So many times I mentioned, whenever shear force magnitude changes, slope of the BMD should change. At B, shear force magnitude is decreasing. When shear force magnitude decreases, slope of the BMD should decrease. The slope of this line should be equal to how much now? 2. And slope of this line equal to 10. So what is the maximum bendment now? 14 hogging. Maximum bendment is 14 hogging. So what is the location of the point of counterflexure? What is the location of the point of counterflexure? This is what now? Point of counterflexure. From fixed support, 3 meters. But here also some students are going to take a section and equate it to 0 now. Not required now. So what are the answers for this question now? Maximum shear force is -10. Maximum bendment 14 kilonewton meter hogging, and point of counterflexure is located at a distance of 3 meters from fixed support. From fixed support. Three meters from fixed support. Now question is completed. If you want to go for the equation, then what do you do it now? Take a section, write down the bendment equation equal to 0. But equation not compulsory, clearly mentioned now. To find out the location of point of counterflexure, bendment equation compulsory when the bendment varies parabolically, UDL and UVL. But it is not required, no equation required now. No similar triangles also required. Suppose this is 10, this is 8. This height of the triangle 10, this height is 8. Then you have to use the similar triangles. Sir, I want to cross check my calculation, then you can check it now. Better to consider left side or right side now? Left side you consider now. Left side you consider now. Can you write down the bendment equation now? It is changing sign between A and B. Take a section, write down the bendment equation. I taken section between A and B. So what the x is taken from the left side. So what the limits now? X is equal to 0 to 2. the plus 10. This is plus 10 minus 10x equal to 0. So directly x is equal to what? 1 meter. But this 1 meter from where now? Left support A. But in the question is asked from right support. So this is a compulsory or optional? Optional. If you want, you can do it now. But directly you can give it now. If you do that one half minute or 1 minute, take a section, write down the bendment, everything now. But here no method is required. So I'm getting the 1 now, but you are given 3. This x is taken from which side? Now left side. But here you are measuring from the right side. Because in the question is asked from the right side, support is asked now. Now what about this blue color vertical and lever? This blue color line is about a lever, and these two are the brackets. Now directly these two will form a couple, bending couple. Two equal parallel opposite form a couple. Which type of load for this beam? Now eccentric axial load. Two equal parallel opposite eccentric axial load will form a couple. So here you are going to only couple will be there. Only bending couple. What the direction of this couple? Anti-clockwise. Direction of the couple is going to be anti-clockwise. And here one constant point load downward. One constant point load is downward. So slightly I am changing this now. So it is equal to one constant point load downward. And what the couple now? Clockwise, 10 into 1. So here you are getting one constant point load downward, one couple clockwise. And this will be about now equal to one axial load. What the axial load now? 10 towards right side, become as a tensile load. And this will give a couple in which direction now? 10 into 0.5, 5, anti-clockwise. So the beam is loaded by total how many loads now? One constant point load, one axial load, and three couples are going to be there. Here anti-clockwise, clockwise, anti-clockwise. So it will be now can you complete the reactions now? Horizontal reaction equal net axial load 10 towards right side. So horizontal reaction will be towards left. Towards left. And vertical reaction, net vertical load 10 downward. Net vertical reaction is vertical, for net vertical load 10 downward. The vertical reaction will be 10 upward. Next, what about the moment reaction? Moment reaction means some students are going to take only couples. Moments also going to be there now. How many moments are there now? Only one moment. Sigma m means sum of the couples and sum of the moments. Couples are 3, but there is a moment is there. How many moments will be there? Number of moments are equal to number of concentrated point loads. How many constant point load? Only one. So can you give the what the sum of the couples at A? What the sum of the couples and moments now? This is the anti-clock, this is the clock. What the sum of these two? 0. But there is a moment is like this now. 10 into what the distance now? 4, 40. 40 clockwise, and this is anti-clockwise. So 40 minus 5. 40 minus 5, 35. 35 clockwise means reaction will be anti-clockwise. So at the fixed end, how many loads? Now axial load is plus 10, tensile. Shear force plus 10, and directly bendment is minus 35. So at A you are getting an axial load, shear force, bendment. But at D only axial load and bendment, no shear force. At D there is no shear force because of there is no constant point load. Sometimes directly they will ask what now? For the axial load, shear force, bend moment and twist moment is the fixed end. Axial load is 10, shear force plus 10, bend moment is what? Minus 35. Twist moment is 0 because there is no twisting couple now. Then what the shape of the ALD? ALD should consist of 2 vertical lines. SFD consists of 2 vertical lines. BMD consists of 3 vertical lines. Then draw a parallel line until next axial load. Where the next axial load? D. So ALD is about a completely rectangle, positive rectangle. Towards left side positive means towards right side is negative. Next SFD. Upward is positive. That is once again plus 10. Plus 10. Plus 10. Then draw a parallel line until next constant point load. In between there is no distributed load, there is no vertical load. So what the conclusion from this SFD? Here to here shear force 0 mean bend moment should be a constant. Here to here shear force should be 0 mean bend moment should be a constant. Next, what about the BMD? Anti-clockwise, anti-clockwise 35, negative. This is what the positive. Anti-clockwise positive. So how much is now? So automatically point of counterfacture will exist. This side I am getting a negative, this side I am getting a positive. Point of counterfacture will exist. Now here how many times you have to calculate the bend moment? 2 times. First neglect it. If you neglect it, what the value now? 10 into 2 plus 20 and this is minus 35. Neglected. 10 into 2 plus 20 minus 35. 10 minus 35. So 20 minus 35. 10 into 2, 20. 20 minus 35 minus 15. Minus 15. So how to join it now? Linear. Next, once again this is a negative, clockwise positive. So 15 minus 10 minus 25. What should be the height of this line? 10. Next, at C. At C better to consider which side? Now right side. At C better to start from the right side. So neglected. So directly what here tier shear force 0. So bend moment should be a constant. Directly what a bend moment is a constant. Because you already know bend moment here, now here tier a constant. Then you consider this value now. Right hand side anti-clockwise positive. Clockwise is going to be a negative. So 5 minus 10. 5 minus 10. Minus 5. So what the shape of CD portion pure bending? The circular arc will be there now. Shear force 0, bend moment is constant. Now to check whether BMD is correct or incorrect now. Number of vertical lines. How many vertical lines now? How many couples are there now? 1, 2, 3, 4. 4 vertical lines. What the height of this line? 35. This height should be equal to this couple 10. This height should be equal to 10. Is a 5. 4 vertical lines. And whenever about a shear force is constant, non-zero constant. Non-zero constant means linear, one inclined line. Here one inclined line. And whenever shear force 0, bend moment should be a constant. Whenever shear force 0, bend moment is a constant. So what are the final answers now? Now your point of contraflexion exists or will not exist, but directly location is known. Which one the point of contraflexion C, but its location is known. So you need not find out the location directly. This is C, the point of contraflexion. Point of contraflexion. So maximum axial load 10 tensile. Maximum shear force plus 10. Plus 10 means it will form a couple in clockwise. Maximum bending moment. Hogging. If these questions are become simple, the credit goes to you. You believed me and you put the right action at the right time. You have gone through all the basics thoroughly. That's why it is becoming simple. But definitely 10 or 20% of students will tell what now? Sir, I am unable to follow now. Means teacher is same, but some students are what now? Becoming sir very easy, very easy sir, बहुत आसान हो गया. But some students are what ना, बहुत मुश्किल हो गया सर, मुझे समझ में नहीं आ रहा है सर, क्या कर रहे हैं आपने. But that category becoming very simple, what 80% will be there or 90, 10 to 20% will tell what ना, सर मुझे समझ में नहीं आ रहा है सर, आप क्या कर रहे हैं, बहुत मुझे परेशान हो रहा है सर, आप क्या कर रहे हो, मुझे समझ में नहीं आ रहे. Means you are not done the action now. That's why I'm going to tell, if anybody is what now, getting a success, the credit goes to what, that friend only, who has believed the teacher, believed the made easy, and struggled a lot. Yes, struggled a lot. Struggled a lot. By sacrificing his short-term interest. Is sacrificing short-term interest. So in the cantilever beam, I not discuss any new conclusion. Cantilever beam, I not discuss any new only reactions. That reaction also already studied now. Same conclusion what you have studied, they're all going to be valid here now. The conclusions which are what now? All valid for any beam. I discuss only what one method, that shortcut method, vertical reaction, force into perpendicular distance with other support. That is valid only in simply supported beam. Remaining all are what a generalized conclusion. They are valid for any beam, even a fixed beam. Even fixed beam also, if you know the reactions, you can do it now. Now I'm coming to the your distributed loads. Distributed loads. Once again, distributed load also what becomes simple. In all the distributed load also what you are doing now? Distributed load also what now? We need same concept only. What you have to do it now? Even distributed load also we are doing the same principle. Mean what now? We are going to convert into a constant point load only. When a UDL is there, we'll find out the total load. Total load. And the total load you are going to represent it by constant point load only. So even distributed load, we need this concept is required now. That's why those you are going to be thorough with this concentrated point load, concentrated moments. For them, the chapter is going to become very easy now. But calculation of reactions are very very important, but don't commit a mistake now. If you made a mistake in the reaction, total problem will incorrect now. Be accurate in calculating the reactions. Some students are, I want to do the question very fastly, sir, but is going to commit a mistake in the reaction. Then total problem is incorrect now. Total problem is incorrect now. So while calculating the reactions, don't try to commit a mistake. Be accurate, be accurate. After calculating the reaction, also cross check it now. Sigma V0, sigma H0, sigma M0. You can see it now. Sum of the horizontal force 0. 10 towards right, 10 towards left. 10 downward, 10 upward, 0. Now calculate the sum of the moments now. Sum of the moments. What is this value now? 10 anti-clockwise. 35 anti-clockwise. Means how much now? 45. And this what now? 5. So anti-clockwise how much you are getting now? Minus 50. And clockwise 10. 10 into 4. 50. Sigma m is 0. This is what anti-clockwise. Anti-clockwise. Anti-clockwise how much now? Minus 45. Here also anti-clockwise. Minus 50. Clockwise how much is now? 10 and 10 into 4. 50 clockwise 0. So like that what now? Before, if you are, when you are practicing, before going for the SFD BMD, check it what now, whether your calculations you are done correct or not now. Otherwise from ALD and SFD also you can check it now. By chance ALD is not close means your horizontal reaction is incorrect. If BMD is not close means what now? Either vertical reaction incorrect or moment reaction incorrect. If SFD is not closed at both the end means your vertical reaction incorrect. If BMD is not closed both the end means your either vertical reaction or moment reaction is going to be incorrect now. SFD, BMD under distributed loads. Most of them are going to be what? This is what? Some students are going to draw the SFD, BMD under constant loads correctly. But distributed load, they are going to make a mistake because parabolas are going to be there. Always in distributed load, UDL and UVL, BMD the parabola. But they are going to make a mistake in when drawing the parabolas. So now you can focus. So you can easily draw the parabolas also correctly now. If I use my procedure now, if I use my procedure for constant load, there is no need you to use your equations. No need to use any equation. Shear force equation not required. Bendment equation not required. Sir, point of contraction required, not required now. Because in case of constant load, bendment is varies linear. So you can use the similar triangles or identical triangles now. If I use my method now, whatever the procedure I followed it now, in that case, to draw the SFD, BMD under concentrated point load and constant moment, no section is required. Directly can do it now. So if we can use this method, you can get the correct answer within a less time and without any calculation. But here some questions is required. Distributed loads, some questions, equations are required. Equations are required. ఓన్లీ రెడీ కావాలి. So most of the textbook, the UDL is represented like this. But actual representation, what a UDL is represented by rectangle. UDL is represented by rectangle. UDL means what now? Load intensity. What this small w is called as what? A load intensity. Uniformly distributed. Uniformly distributed. So UDLs are represented by rectangle. What is the best example for UDL now? Self weight of a horizontal member. Self weight of a horizontal member. Self weight of a horizontal member. Or what the other example now? How to get this small w value now? The small w is called as what? A load intensity. Small w is not as a load intensity or load rating. Load rating. How to get this value now? Assume a person having a length of L meters. A person having a length of L meters sleeping on this beam. A person having a length of L meters sleeping on this beam. Beam length is also same and the person length is also same. Height of the person also L meters now. Is sleeping on the beam with a weight of capital W. A person is sleeping on a beam with a weight of W. Otherwise, assume what now? His weight is 100 kilonewtons now. His weight is 100 kilonewtons. And height of the person is going to be 5 meters. Height of the person is what now? Time being is the 5 meters now. Now what the answer now? Is total weight. The weight of the person is 100 kilonewtons. And is sleeping on a beam having a length of what now? 5 meters. Means its total weight 100 kilonewtons is distributed over a length of 5 meters. Now what is the load at each and every meter? What is the load at each and every meter? What is the load at each and every meter? Total load is 100 kilonewtons. And its weight is distributed over a length of what now? 5 meters. So what is the load at each and every meter? 100 by 5, 20. The 20 is nothing but the small w. The small w is nothing but about a load intensity. Small w is called as a load intensity or load rating. Load intensity or load rating. Other example, assume what now? Now sleeping what now? So everywhere what the at every meter, what the intensity? At every meter it intensity is what now? Total weight of the person is what? The total weight of the person is 100 kilonewtons. And is sleeping on a beam of 5 meters length now, 5 meter length. Height of the beam, length of the beam and height of the person are same. So its total weight is distributed over a length of 5 meters. Weight is 100 kilonewtons and its weight is distributed over 5 meters. So at each and every meter, what the intensity now? 100 upon 5. That is what? 20. 100 upon 5. 100 kilonewton upon 5 meter means what? At each and every meter intensity is 20 kilonewton per meter will be there now. That's why what now? UDL is a rectangle. What the other example will be there now? Assume I kept a one cement bag here now. One cement bag. Next one cement bag. Next one cement bag. One cement bag. One cement bag. So what the total weight of this cement bags is going to be what now? 1 ton is going to be there. Total weight of the cement bags are what? A ton. They are kept side by side. 1 ton. But length of the beam is what now? 5 meters. Length of the beam is what? 5 meters or 10 meters. So what is the intensity at each and every meter? Total weight of the cement bags is 1 ton. But these are kept in what? How much length? 10 meters. So at each and every meter, what the intensity? 1 ton upon 10. That is about 0.1 tons. 0.1 ton per meter. That is the example for UDL. Since every meter intensity is same, then they are represented by rectangle. Next example is what? I kept a one cement bag. Next 2 cement bags. Next 3 cement bags. 4, 5. So when I am going from left to right, what happens now? Intensity will increase. Here 1 cement bag. Next 2, 3, 4. Like this what? This is representing what now? UVL. Uniformly varying load. So UVLs are represented by triangle. UVLs are represented by triangle. Similarly, hydrostatic pressure. That is also going to be what a water tanks, etc. Now hydrostatic pressure, it is also UVL. So actual representation UDL is a rectangle. The actual representation, but for easy convenience for all the textbook they are showing like this now. UDLs are rectangle, mean what the meaning now? Everywhere the height is same. In the previous example, a person is sleeping on a beam with a length of what, height of the person is 5 meters, weight is what, 100. What this height now? At each and every meter, what the intensity? 100 upon 5 meter, mean 20 will be there now. So this intensity is going to be called as 20 Newton per meter. 20 Newton per meter. So small w is called as what now? Load intensity. Load intensity or load rating. Of a distributed load. DL means distributed load in Newton per meter. What is the meaning of this now? Now at every cross section, now you take the any cross section, what the intensity W, then it is called a UDL. If you go for a UVL, what is the meaning of UVL? Intensity will vary linear. In case of UDL, in case of UVL, uniformly varying. Triangle what now? Height will vary linearly. So intensity will be what now? Wx by L. So UVLs are represented by triangle, UDLs are represented by rectangle. Now what should be a first step now? First step is what now? Find out the total load of this distributed load. First you have to find out the reaction. Now total load of the distributed load you have to calculate. How to find out the total load now? Total load can be calculated by area of the plane figure. Area of the plane figure. What the shape of this now? Rectangle, triangle, there are plane figure. Plane figure means 2D figure. So the total weight is going to be given by area of the plane figure. So what the area of a rectangle? Length into height. So W into L. Now what the height of this rectangle here now? Rectangle means everywhere the height is same. What the height of this rectangle here now? This is called as the load intensity at xx. This we are calling as what now? Wxx. What is Wxx value now? W. Rectangle means everywhere height is same. So I have taken an arbitrary cross section. I have taken an arbitrary cross section at a distance of x from the right side now. So what the height here now? W. That only I have written what Wxx equal to W. Now this intensity depend upon x or independent of x? Independent, therefore it is a constant. Now what the next step now? You have to calculate the reaction. Before calculating the reaction, what should be the first step now? Find out the total load of this distributed load. Find out the total load of the distributed load. Total load of distributed load. Distributed load. This can be calculated by two ways now. What the first method now? Integration. Total load is going to be given by integration. Total load. In our case, what the limit for x now? X is taken from the right side. Now lower limit is 0. What the upper limit now? Where next load is acting? The same UD is acting up to what now? Fixed end. In between there is no other load is there now. The same distributed load is acting up to what now? Fixed end. So limits are 0 to L. So limits are 0 to L. Now you have to do the integration. This is the actual method. This is the actual method. What the other method you are going to do it now? Other method is the area of the plane figure. Total load of distributed load is given by, always integration will give the area. Integration will give the area. Area of plane figure of corresponding distributed load. Most of the textbook they are in the second method. Why? Because in all the textbook they are dealing with a UDL and UVL. UDL means rectangle. Rectangle area is known. UVL means triangle. Triangle area is known. That's why in all the textbook they are using this now. But one of the gate paper is given about now. Load intensity is given as a sine function is given. Load intensity is given as a sine function. We don't know the area of the sine curve now. Then what the method you have to do it now? Integration. So who knows this method? They done it now. Who knows this method? They done it now. So wherever you know the area, you can go for this now. But wherever the areas are unknown, then you go for the integration. This is the actual method. And this method. This method can be valid only when area is known. But whenever I want now sine curve area is unknown, then you have to go for the integration. The intensity is given as what now? Sine 3 pi x by L. Load intensity is given as a sine 3 pi x by L. Then you have to do the integration. You have to do it now. So in our case, you can find out the area or what now? Integration I have to do it or area. Anyone you can do it. I am going for the area now. So what the total load here now? In this given case, in case of UDL, total load is given by rectangle area. that is W into L. Sir, I want to go for this method, you can do it now. What the limit for X now? Lower limit is 0, upper limit is L. What the intensity, what this height now? W. If you go for the first method, what I have to do it now? Total load is given by WL. After finding out the total load should be represented by a constant point load. Total load should be represented by a constant point load at the centroid of the plane figure. Total load should be represented by a constant point load at the centroid of the plane figure. Is a plane figure. For rectangle, where you are going to get the centroid? Rectangle, where you are going to get the centroid? Exactly the middle. What is this blue colored dot now? Blue colored dot is about a centroid. After finding out the total load should be represented by a constant point load at the centroid of the plane figure. For rectangle, centroid is exactly the middle. If you go for a UVL, centroid will be about 1/3 from the base, 2/3 from the vertex. So now what is this total load now? Total load. Now next step is about to calculate the reactions. Calculate the reaction. Now can you give the vertical reaction now? What is the total vertical load acting on the beam now? WL downward. So vertical reaction how much now? WL. What you have studied cantilever beam? Vertical reaction equal to net vertical load. What is the net vertical load? What is the total load acting on the beam? WL downward. So vertical reaction will be and what about the horizontal reaction? 0. Horizontal reaction is going to be 0. Then what about the moment reaction? What the net moment at A? What the net moment at A? WL into L by 2 clockwise. So reaction should be anti-clockwise. After finding out the total load, represent the total load by a constant point load at the centroid, that is the L by 2. Now find out the reaction. What is the vertical reaction you studied now? Net vertical load. Net vertical load is WL downward. So reaction should be WL upward. WL upward. And what the moment reaction? What the net moment now? WL into L by 2 clockwise. So this is going to be anti-clockwise. Now can you give the shear force and bendment now? Can you give the shear force and bendment at the fixed end? Directly this will become the shear force now. What the shear force here now? WL upward. WL upward means positive. And what the bendment now? Minus WL square by 2. Minus WL square by 2. But what the shear force and bendment at B? What the shear force and bendment at B? Both are 0. Why? There is no constant point load. To get a shear force, what is required now? There should be a constant point load. Here there is no constant. If it is going to take this a constant, it is not a constant point load. It is the intensity. There is no constant point load. Therefore, here shear force 0. No bendiment. To get a bendiment, what is required now? A bending couple is required. A bending couple. Therefore, here shear force 0, bendiment is 0. Shear force 0, bendiment is 0. Can you draw the SFD BMD now here now? For the shear force now positive, left hand side upward is a positive. Here what the shear force now 0. Everybody is going to take small w. It is not a concentrated point load. It is a load intensity. Since there is no constant point load, shear force 0. Now the question, here to here how to join it now? Here to here what now? Either you can join by straight line or a parabola. Either you have to join by straight line or a parabola or a cubic parabola. Then how to decide it now? How to decide the what now? Variation. How you decide the variation? Take a arbitrary section, write down the shear force equation and bendment equation. If the shear force equation a function of x, linear variation. If the bendment is a function of x square, is a parabola. Now what do you do it now? Already you have taken a section. Now better to consider left side or right side now. To write down the shear force and bendment equation, better to consider left side or right side. On which side least number of loads are there? Left side only distributed load is there. But right side how many loads are there now? One distributed load is there, one constant point load is there, one moment is there. Right side only distributed load is there. Left side what now? A distributed load is there, constant moment is there, constant point load is there. Always better to consider which side now? Right side. So I'm considering the right side. Then what do you do it now? Highlight the shape of this diagram now. I'm considering the right hand side. Then highlight the shape of this diagram now. I want to consider the algebraic sum of the load on the right side. Then you highlight the shape of the diagram, loading diagram on the right side. Right hand side, which load is there now? Distributed load is there. Just now what you have studied, whenever a distributed load, you have to find out the total load. So what is the total load of this now? Area of this rectangle. What is the total load of this now? Area of the rectangle. What is the area of this blue color rectangle? Height is W, length is X. So what is this total load now? Wx. Whenever a distributed load, first you find out the total load. So what is the total load of this now? W into X. And where you are going to get the centroid? Centroid is here now, exactly now. So what is the total load of this blue color triangle? So rectangle. Wx. And what is this distance now? X by 2. X by 2. Now can you write down the limit for x now? X is what? 0 to L. First write down the what is the intensity here now. What the intensity? What this height now? W. Sir, why you are taken minus? I am following the downward load intensity negative. Either downward or upward? No, downward. Downward I am taking negative. So what the meaning of this minus now? That intensity is acting in the downward. Intensity is acting in the downward. Sometimes the question is given, this UDL is given upward direction. If the intensity is acting upward direction, it should be a positive. So what this minus sign is represent now? Downward load intensity. Load intensity acting in the downward. What is the height of the black color line? This is called as what a WXX. Once the reaction is complete, you can remove this total load now. Once you complete the reaction, you can remove this total load. Now what is this intensity? W. What is the downward or upward? No, downward. No. Next. Now what is the shear force definition now? Algebraic sum of constant point load either on the right side or on the left side. I am taking the right side only. Why not left side? Left side, how many constant point load are? 2. One vertical reaction, total load of this portion now. Right hand side, only one constant point load. But left side, how many constant point load? One vertical reaction, total load of this portion now. So that's why I have taken right side. Now what the right hand side downward, the positive or negative, what the shear force now? Shear force at any cross section equal to algebraic sum of the constant point load either on the right side or left side. I am taking the right side. So right side, what the value? No, right side downward is the positive. Positive. Next, what about the Bendiment now? What is the Bendiment equation now? Algebraic sum of the couples and moments. Algebraic sum of the couples and moments. Right hand side couple is there or moments are there? Only moment. Wx into x by 2. Right hand side anti-clockwise positive. Clockwise is going to be negative. That's all. Suppose if you take the left side, how many moments are there? One couple is there, one moment due to vertical reaction and one moment due to total load. That's why you have taken the right side. Right side I am getting one constant point load. But if you take the left side, two constant point loads. You can check it, you will get the same value now. But right side I am getting only one moment. But left side, one couple is there, one moment due to vertical reaction, one moment due to this total load of this red color portion. What the length of this red color portion? Already x means this is L minus x. You take any one, you are going to get the same. I taken on the right hand side. What the shape of this? The rectangle. So what the total load of this now? Wx. This distance is x by 2. What is the shear force definition? Algebraic sum of the constant point load. Right side downward is a positive. And Bendiment is the algebraic sum of the moments. No couple right side. Wx into x by 2 negative. Next somebody is going to take the left side. Sir, I want to check it on the left side. Here, if you take the left side, what is this distance now? This will become as the L minus x. L minus x. Sir, we'll check it on the left hand side. What this blue color portion representing now? The blue color portion representing the left side, and here then one vertical reaction. What is this vertical reaction now? WL. What the moment reaction? WL square by 2. Now what the total load of this blue color portion? Left hand side one constant point load, one constant moment, and UDL is there. So what the length of this blue color portion? Height is W, length is L minus X. So what is this total load of this now? How much is now? W into L minus X. And what about this distance now? Centroid L minus X by 2. L minus X by 2. Now can you write down the shear force now? Can you write down the shear force on the left side? I taken the right side only one constant, but left side what you are getting now? One constant point load. If you take the left side, is a positive or negative? Positive. Next, this is a negative. How much you are getting now? Check it. Are you getting the same equation or different now? Same. Wx. And what about the Bendment equation now? This you have taken which side here now? Right side I have taken now. Whether you take right side or left side, you should get the same. Now I am taking the left side here now. But right hand side, how many couples are this? Couple is there. Minus WL square by 2. And what the moment due to this now? WL into L minus X. And what the moment due to this now? Anti-clockwise negative. Minus check it, simplify this now. You are going to get the same equation. You are going to get it now. Simplified. I am not doing the simplification. Check it. You are going to get the same. Here L means what now? Left hand side I taken now. Don't make it as what now? Left hand side. Whether you take left side or right side, you should get the same now. But what the which one is become simple? The right side is become simple. If you take the left side, the time taking and chance of committing the mistake is more. That's why what you have studied now. Always better to consider which side now, on which side least number of loads are there. If you take the left side, only one constant point load and one moment will be there. If you take the right side, right side one constant point, but left side two constant point load, reaction and the total load. But how many moments will be there and how many couple? One couple is there. Two constant point load means two moments will be there. Due to this and one moment, due to this and one moment will be there. Now, so I am making the board now. This is important now. Remaining will not do, write down all this thing now. Now what the conclusion from this now? Load intensity depend upon X or independent of X? Independent. That's why they called it the UDL. Either depend upon X or independent of X? Independent, constant. But what about the shear force? Function of X. Only the new conclusion is what now? Shear force variation one order higher than load intensity. Load intensity independent of X. But shear force a function of X. Means always what? Distributed load. Distributed vertical load. Shear force variation is one order higher than load intensity. Here to your load intensity constant or varying? Constant. Then one order higher means linear variation. Suppose I am given a UVL. UVL means it is varying linear. So one order higher means parabola will be there. In case of UVL, triangle, height will vary linear. Then shear force a parabola. That's all. That is the only new conclusion. Next you can check it. The bendment variation already studied. One order higher than shear force. Shear force already varying linear. The bendment should be a parabola. Bendment should be a parabola. So what is the conclusion now? Under distributed vertical load, that is UDL and UVL, shear force variation one order higher than load intensity variation. And bendment variation is 2 order higher than this now, or otherwise 1 order higher than shear force. 1 order higher than shear force. Suppose the load intensity varying parabolic. Here I am getting a parabola is there. Load intensity is varying parabolic. What the meaning of this now? Load intensity function of x square. Then shear force a function of x cube. And bendment is a function of x to the power of 4 is going to be there now. Now we can draw it now. Now, what the advantage this now? Whether the equation correct or incorrect, how to cross check it now? Put the x value. What the x value now? 0 here now. If I put it x equal to 0, already got 0. And here, what the x value now? L. If I am going to put the x is equal to L, WL. So how to cross check whether the equation are correct or incorrect? What you have studied now? Always we know the shear force and bendment at extreme end. Extreme end directly known. So, but whether your equations are correct or incorrect, what you have to do it now? Substitute the x value. Here x is what? A 0. X is 0. Shear force 0. Here x is what? The L. WL. Similarly, how to cross check whether bendment equation correct or incorrect now? If I put it x is equal to 0, bendment is 0. And here, what the value now? X is equal to L. Bendment is how much now? Minus WL square by 2. Now, how to join it here to here now? Linear. Remaining questions, I am not going to write down the equation once again now. Directly will draw it now. So whenever you are drawing the SFD, I have to see the load intensity. Since load intensity constant, 1 order higher linear. So if I am getting a inclined line, it should be a parabola should be there now. Next, what about the BMD? Directly to the bendiment. They are coupled with the bendiment. What the value now? Left hand side anti-clockwise is negative. Left hand side anti-clockwise is negative. And here bendiment is 0 because they no couple. So many times I mentioned extreme end to get a shear force, one constant point load is required. Since there is no constant point load, shear force 0. And to get a bendiment, there should be a bending couple should be there. Here there is no bending couple, no constant point. Therefore, both shear force and bendiment are 0. But here there is a constant point load is there, constant moment is there. So both shear force and bendiment are going to be there. Now last conclusion here what now? Now here to here how to join it now? Whenever you draw the SFD, see the load intensity. Since load intensity constant, see a linear variation. And whenever you are drawing the BMD, you have to see the SFD. Because bendiment variation 1 order higher than shear force. It is varying linear, then should be a parabola. But here only the students are going to make a mistake now. I am removing this now. I need 10 minutes, let me complete this now. Then you are going to take a break. Then I am going to close the class. Now, so here BMD. So one student will draw like this, parabola. This is an important one now. If you know this now, remaining is what now? You can easily draw it now, BMDs. But some students are going to remember this now. But another student will draw a parabola like this. So how to draw these parabolas is important now. Otherwise, most of the students they are going to by-heart the shape of the parabolas now. I have to draw a parabola. Is varying linear means a parabola. So one student will draw a parabola like this, other student will draw a parabola like this. Now what is the difference in both the parabolas? Which one is correct means what now? This is a increasing slope. Left to right is a decreasing slope. What is the slope of this diagram? dm by dx will decrease from left to right or increase now? It will increase from left to right. But this will decrease. Sir, I am unable to identify increasing or decreasing. Then what? This will be a what now? parabola with a increasing slope from left to right is a parabola with a decreasing slope from left to right. But some students are unable to identify. If you are unable to identify, what do you do it now? Slope means dm by dx. Draw a one horizontal line. Keep a one horizontal line with a dx. Then draw a one vertical line. So this vertical line it is dm1. So what the slope here now? dm1 by dx. Then keep the x coordinate same. Keep the x coordinate same. Then draw the vertical line. Keep the x coordinate same. Dx is same. Check the y coordinate. When I am going from left to right, y coordinate is increasing or decreasing? dm2 greater than dm1. Means when y coordinate increase, automatically slope will increase. Therefore, the parabola with an increasing slope. Similarly, if you want to check it, what do you do it now? Dx dm1. Now keep the once again x coordinate same. Keep the x coordinate same. You need not measure approximately what the same should be there now. For same x coordinate now, for same x coordinate, y coordinate decreasing or increasing now? Decreasing. So what the slope here now? dm1 by dx. Here slope is dm2 by dx. So when I am going from left to right, y coordinate decreasing means slope is decreasing. Y coordinate decreasing means slope is decreasing. So this will be called as what now? This parabola is called as what now? dm by dx decreases from a to b. A to b. Because dm2 less than dm1. And what about this parabola now? dm by dx increases from left to right. Because so you can draw the two parabolas can be drawn like this now. Two parabolas can be drawn. One student will draw the first parabola, second student will draw the two parabolas are possible. Then which parabola I have to consider? Which parabola I have to consider? What you have studied? Shear force equal to dm by dx. Shear force equal to dm by dx. When shear force constant, slope is constant. When shear force 0 means slope is 0. When shear force increases, slope should increase. When shear force decreases, slope should f equal to dm by dx. F equal to dm by dx. Now how to decide it now? I want to draw a parabola from where to where? Left to right. Now see the shear force magnitude here. What is the shear force magnitude? WL. What is the shear force magnitude? 0. So when I am going from right to left, left to right, shear force magnitude decreasing or increasing? Decreasing. Here what is the shear force magnitude? WL. Here shear force magnitude is 0. So left to right shear force is decreasing. Means slope of the BMD should decrease. Slope of the BMD should decrease. So which parabola I have to consider? The second one. So for this given question, the first parabola is incorrect. When the first parabola is correct, suppose if I am getting a SFD like this now. Suppose the SFD is like this. When shear force increases, slope should increase. But in our case, left to right, shear force decreases. So you should go for a after drawing also you can cross check it like this now. But every time you not write down dx dm, simply draw the one horizontal line, one vertical line. Keep the x coordinate same. X coordinate same. For same x coordinate, left to right, what happened now? Y coordinate decreasing. Here more y coordinate decrease. Therefore, it is called as what now? dm by dx decreasing from A to B. What is the reason now? Because shear force is decreasing from A to B. And shear force equal to dm by dx, that already I studied now. Shear force equal to dm by dx. dm by dx means slope. So left to right shear force decreases means slope should decrease. So always for the conclusion now. Bendiment variation one order higher than shear force, that already known. So here varying linear means parabola. But you can draw the two parabolas like this. But how to decide a parabola? So before drawing a parabola, first check the shear force magnitude. I want to draw a parabola from left to right. So left to right shear force is decreasing or increasing? Decreasing. Since shear force decreases, slope should decrease. You can draw a parabola like this. Then you can cross check it now. Whether your given parabola is correct or incorrect. Whether whatever the parabola you have drawn, correct or incorrect now. Check it like this. Draw a horizontal line, one vertical line. Draw a horizontal line, one vertical line. Check it what the y coordinate decrease means slope decreases. What is the slope of this line now? What is the slope of SFD? What is the slope of the SFD? Constant. Inclined line slope is constant. Why slope is constant? Because load intensity is constant. This slope is a constant. Why? Load intensity constant. So what is the conclusion now? Slope of SFD depend upon the what now? Load intensity magnitude. A to B, load intensity constant. Load intensity constant means shear force. Slope of the SFD should be constant. So I'm going to conclude it like this only now. Always in distributed vertical load, shear force variation is one order higher than load intensity. If shear force is varying if the load intensity is varying cubic parabolically, if the load intensity is a function of x cube, wxx a function of x cube, then shear force should be about the x to the power of 4. Then the parabola with a x to the power of 4. Then BMD will be about a parabola, fifth order parabola. Then Bendiment equation about a fifth order polynomial equation will be there. So shear force variation is one order higher than load intensity. Bendiment variation one order higher than shear force, that already are studied. Otherwise 2 order higher than load intensity. Next. Slope of the shear force diagram depend upon the load intensity. Slope of the shear force diagram depend upon the load intensity. So if I am given a question is like this. What is the meaning of this now? Load intensity varying linear means what the first conclusion now? Shear force should vary parabolically. Is a function of x, triangle, function of x. So shear force a function of x square and bendiment is a function of x cube. So SFD the second order parabola, BMD the cubic parabola will be there. But what the slope of the SFD? How to draw a parabola in this now? When I am going from left to right, load intensity increasing or decreasing? Load intensity 0, here load intensity W, load intensity increasing means slope of the SFD should increase. Slope of the SFD should increase means I have to draw a parabola with a increasing slope. Here what? SFD the parabola or not? SFD the parabola because it is varying linearly. SFD the what now? Parabola. But which parabola I have to draw it now? I have to draw a parabola such that because load intensity increases, when the load intensity increase, slope should increase. Slope should increase means it should be a parabola with a increasing slope. So remember now, slope of the SFD depend upon the load intensity. Slope of the BMD depend upon the shear force magnitude. In our case, left to right shear force magnitude decreasing. Shear force magnitude decrease means load intensity will decrease. Slope will decrease. Slope of the BMD will decrease. But here, load intensity constant, slope is constant. Most of the students are what now? They are going to make a mistake in the parabolas now. Always remember what now? Slope of the Bendman diagram depend upon the magnitude of the shear force. If the shear force magnitude is constant, means what? A slope should constant. That's why you got an inclined line. In your constant load, shear force constant means what? A slope should constant. That's why you are getting inclined line. If shear force increases, F equal to dm by dx. When F increases, automatically what now? Shear force equal to dm by dx. When F increases, dm by dx increase. F decreases, dm by dx decrease. So left to right shear force decreases means dm by dx should decrease. Same thing here also what now? Here load intensity increase, then slope of the SFD should increase. When load intensity increases, slope of the SFD should increase. Slope of SFD depend upon the load intensity. Slope of the BMD depend upon the shear force. So today's lecture is completed. Please always whatever I have given now, please write to refer the conclusions now. Each and every point whatever discussed, that is there in the SFD BMD 36 conclusions. Immediately what now, after class from 5:30. Almost 5:30 is there. So relax for 1 hour. Then go through that conclusions. Each and every conclusion I discuss. If you can go through that conclusion, it will become very easy now. So tomorrow we are going to take so many examples. So many examples we are going to do it. Whenever a distributed load, what the first step now? First convert into a constant point load. Then remaining is same now. Tomorrow same timing. Tomorrow also same timing will be there. Now these questions you can complete it now. These questions you can complete it based upon the class lecture now. Question number 1, question number 3, 4, 5, 6. 11, 12, 13, 16, 17 you have done it, 18 I have already done in the class, 21, 23, 26, 27, 29, 38, 40, 41. So all these questions you can complete based upon a student's lecture now. Right hand side downward is a positive, master, my dear friend. What is the shear force sign convention? Right hand side downward is a positive. Right hand side downward is a positive. That's why I taken positive. What the shear force now? Shear force on the right hand side what now? What the shear force is a positive or negative now? Right hand side downward is a positive. That's why I taken positive now. Sir, you are asking why you are taken a positive in what? The right hand side. What the shear force sign convention? What the shear force sign convention? Right hand side downward is a positive. Left hand side upward is a positive. So lecture is completed today. Will continue tomorrow. So I mentioned 5 o'clock, but it extended up to 5:30 because in between the topic was there.